There are some special matrices that we need to be aware of. The first one is the zero or null matrix. And it is simply any matrix that's just full of zeros. In this case, this is a 2 by 2 zero matrix. You can have a 2 by 1 zero matrix which just had 2 zeros in it. So here we have a 2 by 2 zero matrix. So the zero or the null matrix. The identity matrix. Identity matrices have to be square matrices. And that is rows equals columns. Number of rows equals the number of columns. So, for example, a 3 by 3. So this is number of rows equals the number of columns. So identity matrix has to be square, so the number of rows has to be equal to the number of columns, and it has 1 on what we call the leading diagonal. So let's look at a 3 by 3, and we use capital I for the identity matrix. So this is a 3 by 3. The leading diagonal starts on the top left and goes to the bottom right. So they have to be filled with zeros. Everywhere else, they have to be filled with ones. Everywhere else has zeros. So we said it was a 3 by 3, and it's got 3 rows and it's got 3 columns. Ones on leading diagonal. And it's filled with zeros. And the zeros are in all the other entries. So that's a 3 by 3 identity matrix. The thing about identity matrices, if you go back to, say, addition, the identity for addition is 0. If you add 0 to any number, 5 plus 0, you're going to get back its identity, you get back to 5, so it comes back. With the identity matrix, when you multiply any matrix by the identity, you will get back to the same matrix again. So, for instance, let's just look at the matrix A is equal to A, B, C, D. And the identity for a 2 by 2, it's got 1s on the leading diagonal and 0s everywhere else. So if I wanted to multiply A times the identity, I'd have A, B, C, D. The identity is 1, 0, 0, 1. Now to work out, we've got a 2 by 2, 2 by 2, so the innermost are the same are both 2s and the outermost, so we're going to get a 2 by 2 for our answer. A, B, we get the top row and we just line it up down the first column there, so that'll be A times 1 and then plus B times 0. Now A times 1 is A plus B times 0 is 0, so we get A. We keep the AB going this way, but we put it up against the next column. A times 0 is 0 plus B times 1 is B. Then we get the CD, turn it up this way. C times 1 is C plus D times 0 would be C, and so on. So AI is equal to those two multiplied together and we get back to A. Likewise, and you can do this yourself, IA is equal to 1, 0, 0, 1 times A, B, C, D. And that's also equal to A, B, C, D. And that's equal to A. Now we did say before that multiplication of matrices is generally not commutative. This is the exception, is when you get multiplied by the identity. So AI equals IA equals A. So when you're multiplying by the identity, bearing in mind that A has to be a square matrix, and the identity matrix is a square matrix, that AI will be equal to IA equal A. The transpose of a matrix. So if A is equal to A, B, C, D, E, F, so this has got 2 rows and it has got 3 columns, so it's a 2 by 3. The transpose, now we write the transpose as A superscript T, capital T for transpose, and the rows of the A matrix become the columns of the transpose matrix. So this row here becomes the first column. The second row here becomes the second column of the transpose matrix. So that's the general rule for finding the transpose. The rows become the columns. What is this as a matrix? This will be how many rows? It's 3 times 2. So we just reverse those. So we've talked about the null or the 0 matrix, and it's just a matrix full of zeros. Does not have to be square. We talked about the identity matrix, which has to be square, and a square matrix is where the number of rows equals the number of columns, say a 3 by 3. And the identity matrix is identified by the fact that the leading diagonal from the top left to the bottom right is full of 1s, and we have zeros everywhere else. And we've showed that we call it the identity matrix because when you multiply any matrix by the identity, you get back to the original matrix again, and it doesn't matter which order you do that multiplication. And finally, we talked about transposing a matrix, A and A transpose, where the transpose of a matrix, the rows of the original matrix become the columns of the transposed matrix.